All right, so assuming you guys have no further questions about that, I'm going to get into a very quick session on more advanced debugging technique. The reason that I'll go into this is just to help you guys make a bit better debuggers for the assignment, final and current one. And on Friday, we'll have a detailed section on this as well. But just going into it now, I'm going to cover 3 topics very quickly. The 3 topics I'll be covering are going to be unit testing, test coverage, and the Java Flight Recorder. So these 3 things are more advanced techniques. They're beyond the scope of Comp 250 for sure, but they will help you excel either in the final assignment or writing testers for this assignment, and they'll be very useful to you in your general Java writing careers overall. So the first thing I'd like to go over for you guys will be unit testing. Now, unit testing is the idea of testing small parts of your code one by one. This is like the mini testers that we send you guys. They test small functions of your code one by one. And unit testing actually has some additional features we could be using. There are things called unit test frameworks, which kind of act like your mini tester on steroids. They're able to run your tests, but they also provide you with a lot of infrastructure, which helps you organize and helps you run individual tests, and it helps you use tools that make your tests more robust. These are called test engines, and I believe either today, if I have a bit of time, or on Friday, we can actually show you an example of using one of these test engines, specifically JUnit, to improve the performance of your tests and to be able to do things like running individual tests, which will help you because then you'll be able to debug specifically the parts of your code that are broken. The other topic we'll be covering will be testing. In these tests will be the testing tools that we have access to. So again, showing you guys that you'll be able to run individual tests one by one. It's a very good way to organize. You'll be able to use assertions, which will be able to assert which values should be null, which ones should not be null. For example, if at some stage in your method you need something to definitely never be null, you can just say assert not null and then the variable name, and then it'll tell you that your test has failed if that thing is ever null. You could do that with an if statement, but using assertions and using these test frameworks can make your code a lot more readable and can make your tests a little bit more easier to use. You can run individual tests, as you can see, so you can write a test method, and you can run the method directly Python style instead of doing it in your main method, right? You just run only the tests that fail. And you can do setups and cleanups. So if you need the conditions in your program to be a certain way before a test runs, you can use a before or an after, or a before each and an after each tag to run code before and after each test, which will help set up the environment for the test you're trying to run. And that's also a very helpful feature of unit testing frameworks. And again, Friday we can get into that, and I might get into it very, very briefly today. Now, additionally to be covered will be not to be covered necessarily right now, but additional advantages of these testing frameworks are the use of continuous integration, which is to when you push on GitHub, for example, that all of the tests will run, and it will refuse to let you push if your tests fail. That's a really good way to make sure that all your code is working, and you never ship bad code. And there's also specialized frameworks. So in the future, when you make an API or you might make, use databases or make an Android app, there are specific test frameworks designed for those things. So they'll be able to simplify the process of doing these tests a lot. And so they'll definitely come in handy. Now, additionally, we will cover a topic called test coverage. Test coverage will help you write testers that are much more powerful. Test coverage will let you go through your code, and it'll tell you which parts of your code are actually being tested. So for example, if you're wondering, what is Minitester leaving out? You can run it with test coverage, and that'll tell you which parts of your code Minitester doesn't look at. Right? So test coverage is very important because it lets you see basically how robust a tester is, and it lets you see the weak spots in a given tester. So if you know how to use test coverage, you'll know where Minitester falls short, and you'll know where you should focus your efforts on your own testers. So again, test coverage, a very important topic, and we will see it here. And it can be applied well in improving the mini-tester and in ensuring that your tests are good. If you want to convince yourself that your code is well tested, you should have a test coverage of 100%, which means 100% of your code is actually being run in the tests. Now, to do this, we can show you an example. I'll show you an example today for that as part of our super quick session, and a detailed example on Friday. But for today's basic example, all we have to do is just click the Run with Test Coverage button in IntelliJ. In Eclipse, it's kind of hard to do. You need a plugin, but you can still do it. But in IntelliJ, yeah, you just click the run button that looks kind of like a shield, which is called run with coverage. You have to have the ultimate version of IntelliJ for this, of course. And then it'll actually tell you which methods have been tested and which have not. You can see on the side over here, in this screenshot, the red here means that this code was not tested. So that means the test did not cover this situation. So right here, these situations from 110 to 112, right, that was not covered. But from 108 to 109 was covered. So that way you can see that whatever test was run was only testing one condition. It wasn't actually entering the for loop. It was only doing it when this set was empty. Right? So that's what test coverage can tell you. And in your view here, you can actually see for each class you have how many lines are covered and how many methods are covered. So it's a very useful metric. And test coverage will come in handy. And again, you can use coverage by seeing which things are tested and which are not, and improving your tester as such. Then the other tool we're going to be showing you guys is going to be Flight Recorder. Flight Recorder will let you see how many methods run, and it kind of helps you with time and memory complexity. It lets you see how much memory you're using, how much CPU you're using, how many times each method has run. And it's also a very helpful tool. If you have like an infinite loop or something, you can use Flight Recorder, and it'll tell you which parts of it are running a lot. So you can see here in the Snake AI from a previous tutorial, it ran, 7,000 times, whereas our direction check only ran 131 times, right? It tells you how many times it ran. We can actually see that since the timer ran 7,000 times and the AI method ran 7,000 times, we know that it's kind of OAVAN, right, with the timer calls. We know that each time the timer runs, this method will run. So it's a good way to check how many times every single thing runs. It also tells you about memory usage and everything. And it helps you to see any potential bugs in your program. This is going to be useful because the final assignment has a competition aspect. And to do well in this competition, you have to really understand how fast your code is. And this tool is one of the tools that will help you to maximize the efficiency of your code. Now, one last feature we're going to get into in the session will be our debugger, but doing things in the debugger that are a little bit more advanced. Specifically, we can check overhead and memory. We're not evaluating you on memory complexity, but it could still be interesting to look at. You can see how many of each object you have in your memory. For example, in this example, which is our Snake AI app from a previous tutorial, you can see that we have a very large amount of bytes, a very large amount of strings, and a lot of hash table nodes. And then we can also see, more importantly here, how long each method took. So we can see that Snake AI try move recursive has wasted 9 seconds of time and has been hit 55,000 times, whereas the game has only advanced 24 times. So we can tell that if we want to speed up our app, well, we have to speed up this try move recursive method first, because this method has been hit a large number of times, and it has taken a really long time when it ran. Then the next one, of course, is this line 21, which is at 10,000 hits and has taken almost as much. So we know kind of which methods and which lines are wasting our time, and we know which ones are being run the most. So these features, again, will help you improve your time complexity. They're great in tandem with something like the speed tester. Is it a feature in Eclipse? It's not. This is a feature you guys are going to want to be trying in IntelliJ IDEA, specifically the ultimate version. Again, it's not necessary for Comp 250. These are just features which are to help you do well in the competition that's coming up. You guys are going to want to be able to efficiently use the tools you have available to you. I think you can do it in Eclipse if you get plugins. That's something that I don't know anything about, so that's kind of your own research topic. I'll be showing you guys how to do it in IntelliJ because they make it really simple. So we can see how many times each method is hit and how many of each variable we have. Right, so these are kind of the topics that we'll be covering in the upcoming tutorial, and the most important of these is test coverage. Test coverage is something that applies to this assignment right now. So before we go today, I will be showing you guys a quick example on test coverage, which is a feature in IntelliJ IDEA Ultimate, and we can also try it without Ultimate. So right here we have a test class, tic-tac-test, and if we click more run/debug and run with coverage, again, we need the Ultimate version of IntelliJ for this. It might work in the community version, let's see. We can actually see which methods are covered by our test runner. What does that mean? Well, we can see what % of our classes and methods are covered. If I enter AI, we see 0% is covered. We don't test AI at all. We just wrote it. We never wrote tests, right? So everything is red. We don't know that it necessarily works. If this was your mini tester, you would see that you have to write a tester yourself for the AI class. You can see it's all red. And as you improve your tester, these will turn green as you write tests for them, right? Now, it also, does it cover tic-tac-toe? It actually does not cover most of tic-tac-toe either. What does it cover? Well, it covers it covers the winner ones. It seems it covers vertical winner, right? So it does check all of these lines. It does check all of the horizontal winner lines. It doesn't check any of this method. So you can see our test is kind of bad, right? It only tests a portion of our methods. In fact, the only ones it seems to be testing are diagonal winner, vertical winner, and a little bit of horizontal winner, right? And it doesn't test any of the other methods. So do you guys see that when I click run with coverage, it tells us what the test covers? In fact, it even tells us 36% of our lines are covered, which, assuming that we're just going to mark you based on how correct each line is, means that this tester would guarantee you something around 36%. Now, of course, don't take that as a metric. Of course, we weight each line differently. We don't test you line by line. But as a general rule of thumb, if you have a test coverage of the parts you care about of 30%, chances are you need a lot more tests, right? So hopefully that tool will come in handy for you guys. I've never actually run the mini tester with coverage, so I don't know exactly how good it would be, but this is an example of one of the techniques we'll be using in the upcoming time. And right before we head, we can also just see how efficient our AI is being. So if I enter this AI class, the min-max method, I put a breakpoint on this. I right-click my breakpoint and do not suspend. And I run with the debugger. Do I have the option here to view overhead? Yes, I do. And I will run, oh, I don't want to run tic-tac-test. I want to run tic-tac-toe. Debug, stop and rerun. How big of a board do you want? 3. How many players do you want? 1. Right. Now we can check overhead and we can see that this is running every time, right? So we can see my hits going up as our program runs. This is just counting it up every time we hit min-max. So you guys can see how we can count how many times each method runs by putting a breakpoint on it and checking our overhead. So these are some of the features we'll be using. Again, big in-detail session on Friday. Hopefully that'll be useful to you guys. But what's relevant for today for you guys specifically is going to be our overhead view and our test coverage. And then, yeah, that should be that. Are there any questions about this upcoming content or test coverage, overhead view, and in general, anything that was mentioned today, or anything, or any questions in general? And I'm happy to answer. And otherwise, I'd wrap up. So let me know if you guys have any questions about any of this. All right. So seeing as you guys have no questions, I'll wrap up for today. If you're watching the recording, there is Piazza available to you, as well as office hours and other tutorials where you'll be able to have your questions answered. Thank you so much for coming, and hopefully you guys have an awesome day. Good luck on assignment 3, and good luck on the final. Thank you very much, and goodbye.